All right, today we're going to be simplifying radicals and solving by taking the square root. So let's get started. First thing I want you to think about are perfect squares. Perfect squares are 1, which we're not even going to really care about, 4, 9, 16, 25. The reason we could take the square root of 25 is because square root, you should think of the number 2. So for every 2, 1 comes out. If the square root of 25 is 5 times 5, for every 2, 1 comes out and we get 5. Okay, I tend not to break everything down. I look for perfect squares, so I'm going to kind of do it that way because we all know the square root of 25 is 5. So I'm going to kind of do it that way. So let's talk about this one over here. So square root 500. When I look at that, I see square root 100 times 5. And we know that the square root of 100 is what? And by the way, if this video goes too fast, don't forget that you can pause it, you can go back, you can rewatch it. My suggestion is to watch the whole video and write down notes the first time, and the second time through just watch the video. I know when I did the factoring videos in the past, people don't do that, and then it really showed in class because they had no idea what was going on. So square root of 100 is 10, and there's no more perfect squares than 5, so 10 root 5 is your answer here. Moving on to this one, the root 12 is inside and the 6 is inside. So what can happen is they can both go inside together if they're multiplying. And then as I'm looking at that, I'm saying, okay, well I know in 12 there's a 4 times 3. I'm going to break this 6 up. This is 3 times 2. I know that the square root of 4 is 2, so I can go ahead and do this. Now if I look inside with a 3 times 3 times 2, that's 9 times 2. And what's the square root of 9? 3. So I could pull that out. So I did my 3 times 2, which is 6. I took the square root of 9, which is 3. And we've got 18 root 2 right there. Boom. Moving along here. And remember, if I go too fast, that you're in control. So take control of it. So the square root of a fraction is the same as saying the square root of something over the square root of the bottom there. All right, now I know I see an 18, I see a 9 times 2. But root 13, that's gross. I don't see anything in there. So right now I've got 3 root 2 over root 13. You can't have a radical in the denominator, so you have to rationalize it. To rationalize it, multiply the top and bottom by the radical that's in the denominator. So if we do that, we have 3 times 2 times 13. Square root 13 times square root 13 would be square root 169. The 2 times 13, there's not going to be any perfect squares in there, so I'm going to write root 26, and the square root of 169 is 13. Now watch out, 13 is not in a radical, 26 is in a radical, so you can't intermix them. They're separate things. And there you go. So over here we're going to do the same thing, so we got root 2 over root 11. Got to rationalize the denominator. I actually think this problem's easier. We have root 22, there's no perfect squares in that, over root 121. Square root of 121 is 11. There you go. All right, let's keep going. Another little fraction here. So root 5 over root 12. Root 5 doesn't go anywhere, but we know that there's a 4 in 12, so this would be 4 times 3. So we've got root 5 over 2 root 3. Now again, you can't have a radical in the denominator, so we're going to rationalize it by multiplying the top and bottom by that radical in the bottom. So I'm going to multiply by root 3, multiply by root 3. So there's no perfect squares in 5 times 3. This would be 2 times root 9. So then this is root 15 over 2 times 3. Now you'll notice I show a lot of steps. You may not need to show all these steps to know what's going on, but since I'm teaching you it, I like to show you every single one. All right? And don't forget, if I'm going too fast, pause me. Pause me. Over here, we've got root 8, so let's bust that baby up. I know that there is a 4 times 2 in there. So then we're going to have 6 over 2 root 2. Again, can't have that radical down there, so let's just do this. So we have 6 root 2 over 2 times root 4. What is the square root of 4? And it's 2. So now we've got 6 root 2 over 4. Now 6 and 4 are both on the outside, so you can reduce 6 over 4. And this reduces to 3 root 2 over 2. Ta-da! All right, let's keep it going. Now we got some other stuff going on here. Let's see. Solve by factoring. Okay, so this is the difference of squares. There's a minus in the middle, so you can take the square root of both. And I will tell you that the square root of 289 is 17. So this is x plus 17, x minus 17. Now you take every parenthesis and you set it equal to 0. This is the zero product property. So set those equal to 0, and you solve them. So x is negative 17, and x is positive 17. So numbers 7 and 8 are here because I want to show you there's two ways of solving this. You can actually get x alone in 7 and 8, okay? So you don't necessarily have to factor it, of course, unless they ask you to. You can get x alone here because there's just an x squared. Now, if there was an x squared and an x, you're going to have to factor or use the quadratic formula or complete the square or something like that, okay? But here you don't have to. You could add 289 to the other side. To undo a square, you have to take the square root. And when you take the square root, don't forget about your plus or minus, because positive 17 squared and negative 17 squared both give you a positive 289. So it doesn't matter which way you do it, both of these totally work. Alright, so let's keep on going to the next page. Solve each equation, show work. So I can get my x alone here, so I'm going to add 6 to both sides first. I get 48, divide by 4, and x squared is going to be 12. To undo a square, you take the square root and don't forget your plus or minus. So now we're back to kind of what we were doing at the beginning. We know that there's a 4 in 12, so this is square root 4 times 3. So x is then going to equal plus or minus 2 root 3. There you go. We're going to do the same thing on 10. We're going to subtract our 3 first, and don't forget to bring that negative down on your 5. So we get this. Then we're going to divide by negative 5, and we get 12 over 5, because a negative over a negative is a positive. And then, I'm just going to scooch this way, we're going to take the square root, so x is equal to plus or minus the square root of 12 over 5. Now don't forget that you can break that up. So x equals plus or minus root 12 over root 5. Let's keep going this way. So x equals plus or minus root 4 times 3 over root 5. And then that means x equals plus or minus 2 root 3 over root 5. Now wait a minute, we can't leave this though, because we have a root 5 on the bottom. So what we're going to have to do is multiply the top and bottom by that root 5 to get rid of it. So multiply by root 5, multiply by root 5. So x is going to equal plus or minus 2 root 15 over root 25. And last but not least then, x is going to equal plus or minus 2 root 15 over 5. Again, the 15 and the 5 don't intermix. One's inside the radical, one's outside. You cannot do anything with that. I'm showing you every single step here. Some of you might not need all these steps, but obviously for the notes I want to show them all to you. Okay? So let's look at number 11. On number 11 we have a 1/5 multiplying on the outside. So I'm going to multiply both sides by 5 so I can get my squared alone. Now that this is alone, this whole thing is being squared. Now here, to undo it, I have to take the square root. Okay, so let's go ahead and add our 4 over, subtract our 4 over. Now here's the deal. I always put it in front of my plus or minus. So put it in front of your plus or minus. Just trust me on this one. All right, later on it's going to matter. And then I'm going to break up my 30, but it's only 3 times 10. I don't see any perfect squares in there at all. So I think that is it. You're done with that one. Let's go down here. Use a falling object model. This, h is the final height, h sub 0 is the original height. And it says for problems 15 and 16, but that's for problem 12 and 13. How about that? Okay, a coyote standing on a cliff, 254 feet above the road runner. Alright, so this right here is 254 feet. If the coyote drops a boulder from the cliff, how much time does the road runner have to move out of its way? Well, we know h is the final height, so the boulder is going to end up being here. So h is going to be 0, and we know h sub 0 is the original height. So the boulder was here to begin with, so h sub 0 then must be 254. So let's go ahead and substitute these numbers into the equation that they gave us. So 0 equals negative 16t t squared plus 254. I'm going to go ahead and solve this by hand. So negative 254 equals negative 16t squared. Divide both sides by 16, and I believe when you round, it's 15. And we round to the thousands, by the way. Just always go to the thousands in this class. That's about what you get, and that's what those squigglies mean, approximate. And then you have to take the square root of this. So square root of 15.875. That'll give you t. Now let's think about this. Will your time be positive or negative? Your time would be positive. So when I put this into the calculator, t is going to be approximately 3.984 seconds. Ta-da! Alright, so let's move it down here. That's how long it'll take. Roadrunner bear, get out of the way, it's going to get smashed. How long will it take an object drop from a 575-foot tall tower? Goodness gracious. Alright, so here's a tower, 575, to land on the roof! Uh-oh. Of a 235-foot building. Alright, well, the object is still starting here. Now remember, the beginning height of the object is h sub 0. So our beginning height here, h sub 0, is 575. The problem is, though, it's going to drop to here, so our final height is actually going to be 235 up in the air. Okay, so that's the only difference. So if we use our original formula, which is right here, so h equals, I'm going to write it down, negative 16t squared plus h sub 0. Let's substitute in. So 235 equals negative 16 t squared plus 575. I'm going to subtract my 575 from both sides, and I get negative 340 equals negative 16 t squared. Divide by 16, you get about 21.25. And then you're going to take the square root of that, and I'm going to do my plus or minus. But wait, time is not negative. Can't go back in time. I know you want to sometimes. So we're going to use 4.10. Actually, what am I saying 4.10? 4.61. There we go. Seconds. There we go. So just use the positive of it. All right? And that concludes the lesson for today. We will continue when I see you in class next time. Bye-bye.